Thank you, Mrs. Preeti, for your succinct introduction. Good afternoon, ladies and gentlemen. This is a very proud moment for me to present to you and to the public for the first time some details about this new prestigious project that HAL has started, which is the IMRH, Indian Multi-Role Helicopter. So as you know, HAL has already mastered the technologies in the light helicopter category, and we have 3 successful products to our credit as on today. And this is graduating to the next higher level of the class of helicopters, that is medium lift helicopters. Potentially this is a huge market for not only HAL but for all helicopter OEMs of the world, because as you know, more than maybe 15,000 Mi-17s are in operation at various parts of the world, and these helicopters, legacy helicopters, will come up for replacements maybe 8 to 10 years from now. So the opportunity is big, and HAL has started this project in right earnest and hopefully at the right time, so that when the requirements come up, we will be ready to offer this product to the armed forces first and then to the global market. So with these introductory words, I will start with my presentation. I would request you to just let me finish with the presentation, and after that we will take the questions. Slide. Okay, I will start with a brief introduction about HAL's track record or history as far as rotary wing aircraft is concerned. Our beginnings were very humble. The licensed production of the Cheetah and Chetak helicopters, which were primarily of French origin. The advanced light helicopter was the first project that was sanctioned by the government of India, and which HAL has now successfully developed. We also have a weaponized version of the ALH, which is called the Rudra. And from there we made the dedicated attack helicopter, which is the light combat helicopter. And then the next project was the light utility helicopter, which has recently been certified. And the next big step we are taking is the IMRH, which is the subject of our presentation. Next slide, please. Now, we will start with an assessment of what is the potential demand for these helicopters in the Indian Armed Forces, starting with the Air Force. Before that, a little caveat. This information is from the public domain, so we do not claim the authenticity of these numbers, but I think they are more or less reliable. So the Indian Air Force currently has a fleet of about 239 helicopters, and the estimated requirement is of the order of 250 starting from 2028. Next. Coming to the Army, as of today, the Army doesn't independently operate any medium lift helicopters. It is under the aegis of the Air Force. However, Army has a requirement for class of helicopter they have called as tactical battlefield support helicopters. And 170 helicopters have been projected as the requirement. Next. Coming to the Indian Navy, they have a current fleet of 63, including the contracted 24 MH-60 Romeos, and the requirement projected is 123. Next. So adding up these numbers and assuming some reasonable share for HAL out of these total numbers what I showed it to you, we estimate that IMRH will have a total demand in India for the defense forces for the order of 314 helicopters, and the flyaway cost of these 314 helicopters will be approximately 78,500 crores. And as you know, in any contract for such procurement, there will be an element of ground support equipment, simulators and other supporting infrastructure for O-level, I-level maintenance, etc., which all add together will be estimated to be around 62,800 crores. So we are looking at a total business of 1,41,000 crores during the induction of this helicopter, approximately 20 billion USD. In addition, over the next maybe 30 to 40 years, these helicopters have to be supported in the field. And by making reasonable assumptions, we estimate that 78,500 crores will be the business volume during the MRO phase. Now, in the acquisition phase, you know that as per the new DAP 2020, 50% indigenous content is mandatory for a product to be classified as IDDM, indigenously designed, developed and manufactured. So out of this 1,41,300 crores, 50% is mandatorily to be the value addition within India, which will be something like 70,000 crores, and depending on how much of that will be outsourced by HAL to the private industry, which I assume may be of the order of 50,000 crore, 50%. We are talking about a 35,000 crore business opportunity for the Indian private sector here. And we expect during the MRO phase, we will have more indigenous content. It will be of the order of 75%. So that's again a huge business opportunity, and it's a long-term thing. This market belongs to people who are in it for the long term, not some people looking for quick profits. Next slide, please. Now, as I told earlier, that we are not only targeting the Indian market, as per the interest shown by the ministry and the directives that we have to design this helicopter with the global market in mind. And for us, this is a serious intent. It is just not a slogan or a catchphrase. We are seriously benchmarking our helicopter with whatever is available in the world. So if you look at this graphic here, you have the main contenders. The Mi-17 is of course the workhorse in this category, and the world over this helicopter is used. So this is our primary benchmark. And then comes the S-92, which is of similar weight as our IMRH and a highly efficient machine. Then we have the AW101, of course, a higher weight category of 15 tons, but it's again a very popular aircraft. The next one is the NH90, made by a consortium in the Europe, and the EC725, again a European product. So we are up against some very established, well-entrenched international players. We are aware of that, and that's why I said our intent to match these helicopters is a very serious one, and every aspect of our design we are benchmarking to the best features available in all these helicopters. Next, please. The program, in short, has the elements which are listed here. Primarily the design, most of which will be done by the Rotary Wing Research and Design Center of HAL in Bangalore. And next is the development phase, where we have to manufacture basically 3 flying prototypes, one structural test specimen for destructive testing, and one ground test vehicle will be the test bed for most of the systems before the first flight of the prototypes. This will be followed by possibly 3 to 4 years of ground and flight testing to certify all the systems. And the certification is expected in about 7 years from the date of sanction. Sanction is awaited. We expect that maybe within a year or year and a half we will have a government sanction in place. And the certification, of course, will be followed by the series production of these 300 and odd helicopters what I mentioned. Next, please. This is again, as I told you, this is the first time we are opening up some details of this helicopter to the general public. So if you see the broad dimensions of the helicopter, the rotor diameter is 21.2 meters, tail rotor diameter is 4 meters, And a little later on, I will give you further details of these inner details of this aircraft. Next one, please. This is a 3D digital model. HAL has been working on it from approximately 2017. So we have now done work for more than 3 years. And we now have a 3D digital mock-up of the helicopter with all the LRUs, equipment, including antennas, are located and positioned in the aircraft. Whatever changes are required when the final requirements are issued by the armed forces, we will make those minor changes. But our predictions or our estimations earlier that what could be the requirements from the armed forces, which are matching with a draft version of the requirements which we have studied recently. So we don't anticipate any big surprises or thing. We are well prepared with our design. Next, please. We have made a small walkthrough of the helicopter. So I would request this video to be run. So the aircraft has multi-mission, multi-role capability, and the true sense, 4,000 kg payload at sea level and maximum takeoff weight of 13 tons. At altitude of 4 kilometers, the payload is 1,500, which I don't think any helicopter in the world today can offer. Service ceiling is 6.5 kilometer. Then maximum speed is 260 at ISA plus 15 degrees centigrade conditions. We have a composite rotor system. Transmission is 100% HAL design. The engines, of course, will be from foreign OEMs. We have 2 OEMs with whom we are discussing. And the airframe is primarily made of composites with main frames being metallic. The landing gear is again HAL design. It's a crash-worthy landing gear meeting international crashworthiness standards. We have a smart cockpit with large area displays. And the airframe is designed in a modular fashion. This is one area where we are looking forward to private sector participation in making the airframe for the IMRH. These are some details of the transmission system design. As you can see, we have gone quite well ahead in the design. These are just not graphics, but these are actually the correct gear ratios, etc., which have been decided. We also provided for folding of the blades, although it is not there in our requirements from the Army and Air Force side, but still for parking efficiently in the underground hangars, etc., we are providing a folding facility. The other systems in the aircraft like hydraulic systems, flight control systems, all of these layouts we have completed. And in most cases we know who are the potential vendors for all the LRUs that are required. The flight control system. Some details of the landing gear. Now you can see all the LRUs we have just shown here. Of course, they are not too visible, I'm afraid, but still, what we want to show is that all these LRUs equipments have been already positioned inside the helicopter. The layouts have been completed. The avionics system, this will be state of the art and maybe the best in the world today. The mission systems which are there as part of the helicopter. and the general mechanical systems like the air conditioning system, for example. So basically it's a cargo helicopter with troop transport, tactical troop transport capabilities, but in the weaponized form it is a lethal platform for attack. It will also have a self-defense suite of products. We can drive certain vehicles used by the army, for example, directly into the cabin. There is a ramp door designed for that purpose. And we have the biggest cabin volume available in this class of helicopters. So the armed role, of course, there is an armament boom on which 4 stations will be available with a total of 1,600 kgs of weapon load possible. This is a perspective view of the cabin from the inside. This is a cockpit console and the displays, the large area displays which we envisage. So there you can see that most of the items are already modeled, positioned inside the helicopter. So this is the IMRH walkthrough. Can we go to the next slide, please? Coming to the basic building blocks, as I told you, the most critical systems like the rotor system, transmission system, landing gear, displays, automatic flight control system. For all these we have made very good progress, and we are very clear about our task. So the definition of most of these systems is at a very advanced stage. Next, please. These are the roles envisaged for this helicopter. On the left side you have the unarmed roles, and on the right you have the armed roles. The unarmed roles are fairly conventional. Those who are familiar with helicopter operations, no need for elaboration. On the right hand side, the armed roles, you have special heliborne operations, the commando special forces tasks, anti-insurgency or counter-insurgency operations, and fire support to ground troops, combat search and rescue, then air defense against UAVs, and then urban warfare. These are the armed roles as per the requirements of the customers. Next, please. These are the broad specifications of the aircraft. Of course, certain of those specifications we have not brought it here because they are sensitive in nature. But these are the kind of specs normally you will be finding in Wikipedia or such generic sources. The all-up weight of the helicopter is 13 tons, as I told earlier. But in certain missions, we will permit maximum takeoff weight of 14.2 tons. The service ceiling is 6.5 kilometers, and the hover out of ground effect ceiling is 4.5 kilometers, which I think none of the contenders, what I mentioned earlier, globally, they don't have this capability. We can carry internal fuel to the extent of 2,000 kgs, which gives an endurance of about 3 hours plus. We can carry 24 troops in the default configuration and 36 in the high density seating configuration. The max cruise speed at ISA plus 15 condition is 260 kmph. This is indicated airspeed. The payload at sea level is 4000 kg. Of course, the Mi-17 also can carry 4000 kg at sea level, but the range we are offering is at least 25% better than what the Mi-17 can offer. And then, as I told you, there are 4 weapon stations, and the inboard stations are of 500 kg each, and the outboard stations can carry 300 kgs of armaments. The range is 800 kilometers at sea level. Rotor diameter is 21.2, which matches with the Mi-17. And this is a fairly large rotor diameter because we have very special requirements to operate at very high altitudes. So this rotor diameter is one of the key requirements for that. Similarly, for the tail rotor, we have chosen a 4-meter diameter, which is higher than that of the Mi-17, because again, our high altitude requirements are very unique and we don't want to fall short in any requirements at all. Next slide, please. This is the set of line replaceable units or equipment, sensors and the weapons which are going to be part of the helicopter. The electro-optical pod, the helmet-mounted display system, missile approach warning system, laser warning receiver, then directed infrared countermeasures, the radar warning receiver, etc. These are all fairly standard equipment in most of the helicopters. Now the idea of presenting it here is to give a perspective to the industry about how can they participate in this program. Some of these equipment here, especially the navigation, etc., our HAL divisions themselves are making. But certain critical sensors, like for example the DIRCAM or the missile approach warning system, etc., are supplied by global vendors. And as all of you must be aware, we have now a Make in India purchase preference policy, which is promulgated by the Government of India, according to which you have to either qualify as a class 1 vendor, local vendor, or as a class 2 local vendor to be eligible to participate in these tenders. Of course, you can respond to our tenders as a global OEM, but because of this purchase preference policy, the Indian vendors who meet this criteria of value addition, which is 50%, they can be given preference. So therefore, as a strategy to those OEMs, our suggestion will be to set up companies in India with the requirements what are specified by the government as far as definition of an Indian company is concerned. And if you can show a value addition of at least 25-30% in India, you stand a very good chance of winning the orders from HAL for these helicopters. This is a change scenario where earlier we could freely issue global tenders and then select the equipment. So what I am suggesting is that those who set up companies in India today stands a better chance of winning these contracts. And you can either set up companies or you can you can take Indian companies including BEL or HAL as your partners and make this equipment in India. So these a lot of opportunities are there for everyone in this. Next slide, please. We have already completed phase 1 of the wind tunnel tests of the helicopter, and the results so far are very encouraging. The observed drag values of the helicopter are better than what we have estimated. In other words, the performance can be better than what we have shown here, but we will confirm it only after flight testing starts. The wind tunnel model itself is made in a modular fashion. You can see a lot of external appendages are there, so that we can test them in combinations and then assess what are the aerodynamic characteristics. So we get more information about the flight characteristics of the aircraft. Next, please. This is the airframe. broadly the modules we have envisaged in the airframe. This is again an area where the private industry can participate. In the projects like LCA, we have started involving the private sector only in the production stage. However, in this case, we would welcome private participation right at the design stage itself, so that the vendors who take up manufacture of these modules in the development stage can continue to become the suppliers in the production stage as well, so that the learning that is involved in perfecting the manufacturing of such components and assemblies, that process can run concurrently with the development phase, so that when the production comes, these private ecosystem will be well equipped to supply parts and assemblies to us. And we would welcome if major fuselage modules are supplied as it is, and we are also open to models where the private sector, those who are capable, can also take up the detailed design of parts based on the geometry defined by HAL and supervision of HAL. Next, please. This is a broad overview of the rotor system. It's a bit technical. HAL people present here anyway know all these details, so, and for general public it is a little overheads. I will not enter into the details, but this is just to show that we have done serious work on these designs and more or less come up with all the kinematics, sizing of the components, stress analysis. All of this has been already completed. Next, please. This is again some views of the transmission system. The whole transmission system weighs 1 ton. So it's a huge thing. Here again, I know there are private companies in India who can do the gear machining and the MGB, the main gearbox casing, which is again a casting. So the forging of the gears or cutting, machining, gear cutting, these are all the areas where the private sector can participate. Next. The engines, of course, as I told you, they will come from foreign OEMs, because right now in India there are no engines available of this order. We need actually approximately 2000 kilowatts from each engine, and we use 2 engines in this helicopter. Next, please. So this is a tricycle landing gear. As of today, it is not retractable because the Army and Air Force are not interested in a retractable landing gear, but in parallel we have kept a design ready for a retractable version as well. It has got the regular features like parking, brakes, steering, passive steering, etc. And it is crash worthy to the extent of 6.1 meter per second vertical sink rate, which meets the international standard for crash worthiness. Next, please. It's a broad architecture of the electrical system. There are 2 generators, and we also have an auxiliary power unit on the helicopter. So in case of a failure of the main electrical system, we can switch on the auxiliary power unit and then continue the mission uninterrupted. In addition, we have batteries to back up for a half-an-hour flight in case of an emergency of both these generators failing, which is extremely, extremely rare. Next, please. This is the overall avionic architecture of the helicopter. At the architectural level, we have finished with our conceptualization, and some fine-tuning will be required in view of the new requirements which Air Force has projected. Otherwise, we are through with it. The next stage, of course, is to define all the ICDs, intercommunication between all these equipment you see on the screen. The software development for this is one of the challenging tasks in the IMRH. Once again, we would welcome companies who are experienced in the field of developing software for aeronautical applications. We can work out certain partnerships where certain elements of the software can be developed by the private sector, and HAL, of course, will do the total integration. And the software architecture will be defined by HAL, based on which the private sector can participate and contribute. Next, please. This is a general view of the cockpit, how it will look like with the 2 large area displays and the central console packed with switches and other kinds of knobs and controls, etc. Next, please. As far as schedule is concerned, as I told you earlier, it's about 7 years what we are targeting. This 3.5 years of advanced work what we have already completed is going to help us in meeting this schedule. And as you would have already understood from my presentation, we have done quite a lot of serious work, and therefore we are well prepared to start sprinting the moment the government sanction is available. And as I told you that Mi-17s are going to be phased out from 2028. So if this project is started in 2021, we are exactly dovetailed with the phase out of the Mi-17, and we will be ideally positioned to cater to the demand. Next. There is a small movie to wind up the presentation.
Rotary Wing Research and Design Center of Hindustan Aeronautics Limited has launched the design and development studies of Indian multi-role helicopter IMRH, indigenously designed to meet the requirements of Indian Armed Forces. IMRH is a 13-ton class medium lift helicopter featuring 5-bladed articulated main rotor with spherical elastomeric bearings and composite blades, 4-bladed articulated tail rotor with composite blades, advanced transmission system with emergency lubrication system, composite fuselage, glass cockpit with advanced avionics, dual-channel AFCS, crash-worthy design, self-sealing fuel tanks, twin engine with dual-channel FADEC and APU. Large cabin volume comprising of increased height, width and length as compared to any helicopter of this class. IMRH is capable of carrying 24 to 36 troops with ease of ingress and egress of men and material. Designed to operate from sea level to 6.5 km pressure altitude with high payload capability, IMRH will meet the mission requirements of Indian Armed Forces and will have Army and Air Force version, Navy version, Civil version, VIP and VVIP variants. IMRH is best suited for all weather conditions and a multi-role helicopter with quick roll changes, equipped with sophisticated systems for counter-insurgency operations, troop support, search and rescue, disaster relief, and medvac operations. HAL has completed the preliminary design studies and wind tunnel test of 1:10 scale model of IMRH. The IMRH meets requirement of Indian Armed Forces at extreme altitude and weather conditions. The civil variant of IMRH will be designed for superior luxury and comfort. Indian multi-role helicopter is the next generation indigenous product after Dhruv, Rudra, LCH and LUH from the stables of HAL.